Good day, everyone. I'm Tang from the School of Pharmacy, Monash University, Malaysia. The title of my talk today is The Protective Effects of Zinc Oxide Nanoparticles Against Paraquat-Induced Toxicity. In this study, we are trying to decode the mystery of Parkinson's disease. Parkinson's disease is a progressive neurodegenerative disorder characterized by selective degeneration of dopaminergic neurons in the substantia nigra of the brain, which results in impaired body movement. Parkinson's disease is a multifactorial disease. The main contributor to the development of the disease are oxidative stress and exposure to environmental toxins such as paraquat. Paraquat is a toxic chemical that is widely used as an herbicide, primarily for weed and grass control. Many countries, including Malaysia, have already banned paraquat due to its acute pulmonary and cutaneous toxicity. Despite the ban, some irresponsible farmers still use this illegal poison due to lower costs. Paraquat can induce oxidative stress and has long been associated with Parkinson's disease. Zinc oxide nanoparticles have numerous pharmaceutical and biomedical applications. Zinc oxide nanoparticles exhibit antioxidant properties and have been implicated in the treatment of oxidative stress-related diseases, including cancer and diabetes. Since oxidative stress plays a crucial role in the pathogenesis of Parkinson's disease, we hypothesize that zinc oxide nanoparticles can be used to treat Parkinson's disease. This study aims to examine the protective effect of zinc oxide nanoparticles against paraquat-induced cell death in human neuroblastoma SHSY5Y cells. Here is our study design. The 0-hour time point is when we seed the cells. After cell seeding, we waited for at least 24 hours before we expose the cells to the following treatment conditions. For the pre-treatment, after 24 hours of post-seeding, the cells were pre-treated with zinc oxide nanoparticles for 24 hours, followed by co-incubation with zinc oxide nanoparticles and paraquat for another 48 hours. For the co-treatment, the cells were treated with zinc oxide nanoparticles and paraquat simultaneously for 48 hours in total. And for the post-treatment, the cells were post-treated with zinc oxide nanoparticles and paraquat for 48 hours after a 2-hour initial exposure to paraquat. All these 3 treatments were terminated at 96-hour time point post-seeding. We then perform an MTT assay to quantify cell viability. These are the results after subjecting the cells to pre-treatment, co-treatment, and post-treatment protocols. First, let us look at the figure on the left, which is the pre-treatment condition. The white bar is the untreated control. The blue bars are the groups treated with zinc oxide nanoparticles. The red bar is the group treated with paraquat only. And the purple bars are the paraquat groups treated with zinc oxide nanoparticles. We found that the exposure to the zinc oxide nanoparticles alone for the concentrations ranging from 0.1 to 0.7 microgram per mil do not affect the cell viability. 300 micromolar of paraquat reduced the cell viability to less than 50%. However, the cell viability was significantly higher by about 10 to 20% for all paraquat groups treated with zinc oxide nanoparticles. Similar trend was also seen in cold treatment and post-treatment conditions. We further examine if zinc oxide nanoparticles exhibit any free radical scavenging activity using DPPH assay. In general, percentage inhibition of DPPH should increase with increasing concentrations of free radical scavengers. In this study, we use ascorbic acid as a positive control. And we found that for zinc oxide nanoparticles, the percentage of DPPH inhibition was close to 0 for all concentrations tested. Just to recap what we found in this study, zinc oxide nanoparticles attenuated paraquat-induced cytotoxicity in SHSY5Y cells. Zinc oxide nanoparticles do not exhibit direct free radical scavenging activity. In conclusion, zinc oxide nanoparticles are neuroprotective as they can attenuate paraquat-induced cell death. They could be a promising agent for the treatment of Parkinson's disease. This study warrants further investigation to determine the neuroprotective mechanisms of zinc oxide nanoparticles. That's all from me today. Thank you and stay safe.